Today I will be demonstrating a kindergarten math lesson using the concrete representational abstract model. This model uses manipulatives within the concrete stage to show students how to solve the problem. Then it moves to the representational stage where students use pictures to solve the problem. And finally, to understand more abstract concepts, students will use mathematical symbols to finally solve the same problem.
The Nevada Common Core State Standard that will be addressed within this video is for kindergarten. It is the K.OA.A.2, where students will solve addition and subtraction word problems and add and subtract within 10 by using objects or drawings to represent the problem. The problem that will be used throughout this demonstration is, Allie has 3 red cars. Mark has 5 green cars. How many cars do they have in all? This is the worksheet that students will be given in order to follow along with the lesson. In the first section, students will be using manipulatives along with the teacher. In the second section, labeled pictures, students will be drawing a pictorial representation of the problem. Finally, on the bottom section that's labeled numbers, students will write an equation to solve the problem. This is a closer view of the worksheet that students will be using throughout the lesson. I will first be demonstrating the concrete phase using counting blocks as manipulatives. In the following example, I will be showing how to teach the concrete stage of this problem to a kindergarten classroom.
Good morning, everyone. Today we're going to learn about adding using the numbers 1 through 10.
First, before we begin, let's read the problem that we're going to work on today. The board says, Allie has 3 red cars and Mark has 5 green cars. How many cars do they have in all? We're going to use a couple of different strategies today, but first, I'm going to put a pile of manipulatives on your desk. You have a pile of green blocks and a pile of red blocks. The green blocks represent the cars that Mark has, and the red blocks represent the amount of cars that Allie has. What you're going to do today is figure out how many cars they have in all. So the first step we need to do is look at the problem. We know that Allie has 3 red cars. I'm going to use these red blocks to represent those red cars. So what I'm going to do first is place these 3 red blocks, because she has 3 red cars, into a pile on my desk. Once I do this, you're going to do the same thing on your desk. I'm now going to place 3 red blocks on my desk to show the 3 red cars. So here's 1, 2, 3 red blocks. These red blocks again show me how many cars that Allie has. Now let's look back at the problem. We know that Allie has 3 red cars. I need to figure out how many cars Mark has. When I look back at the problem, it says that Mark has 5 green cars. Like Allie, we use counting squares to represent the cars. We're going to do the same thing with Mark. So I'm going to take 5 of my green counting squares and put them into a pile to show how many cars that he has. In my separate pile, I am now going to place 5 green squares to show Mark's cars. So I have 1, 2, 3, 4, 5 counting blocks. Now that we know how many cars each person has, we need to figure out how many cars they have in all. So what do you think in all means? After the teacher poses this question, they should allow students time to think about how in all relates to the problem in front of them. Students have learned before in counting and with addition that in all signifies an addition problem. Once students can make the connection between adding and the word in all, they will be able to solve this problem. Looking at our problem, we know that we need to find how many cars that they have in all. In our 2 separate piles, we show that Allie has 3 red cars and Mark has 5 green cars. In the discussion we just had as a class, we figured out that in all means that we need to combine the 2 piles in an addition problem. We can do this by taking the amount of cars that Mark has and combining that with the amount of cars that Allie has. So what we're going to do now is take our counters and put them all into one group instead of 2 separate groups. Here we can see that Allie has 3 different blocks representing 3 cars. Here we have the 5 blocks representing Mark's 5 green cars. We're going to combine them now into one pile instead of 2 separate piles because addition means we need to combine the 2 numbers. If I look here now, my next step is to count how many I have in all. So if I do this, I have 1, 2, 3, 4, 5, 6, 7, 8 different squares on my table, meaning that I have 8 different cars. What I want you to do now on your desk is take your 2 separate piles and put them into one pile. Once you do that, I want you to count and see if you have 8 blocks as well. We now know by counting all of the blocks that we have together that there are 8 cars. Because those blocks represent the cars that Allie and Mark have, we know that there's 8 cars in total when we combine them. Although students won't be directly writing on their worksheets during this portion of the lesson, they will be using the different blocks at their desk to demonstrate the problem in front of them. They will follow along as the teacher models the problem and do the same thing at their own desks. Now, I will demonstrate the representational phase using drawings. In this portion of the lesson, I will be using pictures to demonstrate the same problem that students have already solved using manipulatives. Now I want you all to look at the second part of your worksheet where it says pictures. What you're going to be doing is drawing a picture to represent the same problem we just solved as I write the problem here on the board. Can I get a volunteer to read the problem again? Thank you for reading the problem out loud. Now what we're going to do is use pictures to show the same problem that we just solved with the counters. So we know that Mark has 5 green cars and Allie has 3 red cars. What we're going to use is different pictures to show the amount of cars that Mark has and the amount of cars that Allie has. So what I'm going to do is use squares to show Mark's cars and circles to show Allie's cars because we know they have different types of cars. So what I'm going to do is draw 5 squares to show how many cars that Mark has. Remember, these squares represent the cars. So I have 1, 2, 3, 4, 5 squares. Remember, these squares are the cars. On your worksheet, I want you to draw these 5 squares to show Mark's cars. Now what we're going to do is draw circles to represent Allie's cars. So what I'm going to do here, I want you to do the same thing on your paper, is draw 3 circles to represent her 3 red cars. Since we need to find out how many cars they have in all, we know that we have to add these 2 groups together. So we're going to combine them. So in order to do that, I'm going to draw this arrow to show that I'm combining the 2 groups. So what I will do then is draw 5 squares, so 1, 2, 3, 4, 5. These 5 squares are Mark's cars. We're going to combine those with Allie's cars. So now I'm going to draw 1, 2, 3 circles to represent Allie's cars. Now they're combined in one group, so we've added them together. Now that you've drawn the 2 groups together on your boards, our final step is to count how many we have in all. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. This shows me that when I combine Mark and Allie's cars, they have 8 in all. If you think back to when we used the manipulatives, those counting blocks, you had 8 cars at the end. Here, we also have 8 cars. So those are 2 different ways that you can solve. The picture section is the section that students are expected to complete during this portion of the lesson. They are using this portion while the teacher is demonstrating the problem on the board. Like the teacher, students will draw 5 squares to represent the amount of cars that Mark has and circles to represent the amount of cars that Allie has. By drawing an arrow to the combined number of cars, students are showing that when Mark's cars are combined with Allie's cars, there will be a total of 8 cars. Finally, I will be demonstrating how to use mathematical symbols to solve the problem in the abstract stage. In the final stage, I'm going to demonstrate a lesson using the abstract model to solve the same problem. In this stage, we'll be using mathematical symbols to solve the problem. What I need you all to do now is look at the bottom part of your worksheet where it says numbers. What we're going to do now is write an equation to solve the problem. So we've already used counting blocks and a picture to solve. Now we're going to use numbers and mathematical symbols to solve. So when we look back at the problem, we know that Allie has 3 red cars. So what I'm going to do is write the number 3 to represent how many cars that she has. Looking at this problem, I also know that Mark has 5 green cars. So what the next step would be is to write how many cars that Mark has. So we know here that this 3 is Allie's cars, and this 5 represents Mark's cars. Now that we've used numbers to show how many cars Allie has and how many cars that Mark has, we need to figure out which operation symbol we need to use within the equation. So earlier we talked about how many cars do they have in all. We need to figure out which symbol means in all. Before we learned that when you have addition, we use a plus sign, and when we use subtraction, we use a minus sign. We need to figure out which one we're going to use in this problem. Before we talked about in all means combining the 2 groups. So when we combine things, that means adding. So what we're going to do is use a plus sign between the 2 numbers. This means that I'm going to add the 5 cars to the 3 cars that I already have. Now that we have an expression written out, we need to make it an equation by putting an equal sign. So I know that if I combine 3 and 5 from what we've learned about counting, that equals 8. So that means that if I take Allie's cars and combine them with Mark's cars, I have 8 cars in total. So if we think back to everything we've done before with the counting blocks and the pictures, every time we end up with 8 cars at the end, showing that we could either use blocks, pictures, or numbers to solve the same problem. In the last portion of the lesson, students will write on the number section how to solve the problem using an equation. They should have written 3 plus 5 equals 8, as the teacher wrote the same example on the board. In conclusion, this lesson shows students how to represent the same problem using 3 different strategies to help them conceptualize and understand the terms in more abstract ways. Students will first, again, use manipulatives to solve the problem at their desks while the teacher demonstrates it to the class. Once students have mastered using manipulatives to solve the problem in the form of counting blocks, they will move on to a representational phase where they are drawing the picture to represent the same problem. In this lesson, the teacher shows the students on the board how to solve the problem using a square and a circle, and students follow along and do the same thing at their own desks. Once that is complete, students will then move on to a more abstract phase of the problem where they are actually using mathematical symbols, including the addition sign and the equal sign, to solve the same problem. By the end of the lesson, they have used 3 different strategies to solve the same problem. Using these CRA strategies, students are able to transfer their knowledge of counting and apply it to addition. They're able to represent the problems in front of them using pictures. And finally, they are able to apply this problem to real-life situations and other math problems to real-life situations. For instance, like they did in this problem, students thought about how adding together all the toys within the classroom could see how many toys they have all together. Using these strategies, students can make this lesson and math more meaningful to their everyday lives.